The most likely cause of the buzzing in the sound equipment when the air conditioning unit turns on is electrical interference. When the air conditioning compressor starts, it draws a significant amount of current. This current draw can generate electromagnetic fields that interfere with sensitive electronic devices like audio amplifiers. A few troubleshooting steps should be taken to mitigate the issue. Firstly, grounding and bonding is key to minimizing electrical interference. Make sure that the sound equipment is properly grounded. Verify that the ground wire from the electrical panel is securely connected to the amplifier chassis. Also, all metal components should be bonded together using insulated bonding wires. This includes the amplifier rack. Secondly, even if the sound equipment is on a separate circuit, the electrical interference may travel through the electrical panel or the building's wiring. Consider running completely new circuits for both the air conditioning unit and the sound equipment. It is important to make sure that these circuits are physically separated from each other in the panel and throughout their runs. Thirdly, install a power conditioner or surge protector between the sound equipment and the electrical outlet. These devices are designed to filter out noise and interference that may be coming from the air conditioning unit or other sources on the electrical system. Fourthly, noise suppressors can be installed on the amplifier input and output lines. These can help to reduce any residual electrical interference. Fifthly, shielding the amplifier wiring or using shielded audio cables might be required if the previous steps don't completely resolve the buzzing. Shielded cables and wiring can help prevent interference from external sources. Additional tips to consider are 1. Use a multimeter to measure the voltage at the sound equipment while the air conditioning unit is running. Look for any voltage fluctuations or voltage drops. 2. Test the sound equipment with the air conditioning unit turned off. This will isolate any other potential sources of interference. 3. Contact a qualified electrician to assist with troubleshooting and resolving the issue safely, especially when dealing with electrical panels and wiring. They will have the expertise to properly diagnose the root cause of the interference and recommend the most appropriate solutions. When an air conditioner cycles on, it requires a great deal of power to start its compressor and any other fan motors it may have. This can cause a temporary voltage drop on the circuit that it is on. If the sound equipment is on the same circuit, or a circuit that is close by in the electrical panel, this voltage drop could affect the performance of the sound equipment. The voltage drop can create a temporary imbalance in the circuit, which can cause the sound equipment to produce a buzzing or humming noise. The electromagnetic interference from the air conditioner can also cause the sound equipment to buzz or hum. When the air conditioner's compressor and fan motors start, they generate electromagnetic fields. These fields can induce currents in the sound equipment's wiring, which can then be amplified and heard as noise. There are several things that can be done to reduce or eliminate the electromagnetic interference. Firstly, make sure that the sound equipment is properly grounded. A good ground will help to dissipate the electromagnetic interference. Secondly, use shielded cables for the sound equipment. Shielded cables will help to block electromagnetic interference. Thirdly, keep the sound equipment as far away from the air conditioner as possible. The further away the sound equipment is from the air conditioner, the less electromagnetic interference it will be exposed to. If the sound equipment is particularly sensitive to electromagnetic interference, it may be necessary to use a power conditioner. A power conditioner will filter out the electromagnetic interference from the power line. In severe cases, it might be necessary to install a dedicated electrical circuit for the sound equipment. A dedicated circuit will isolate the sound equipment from other electrical devices that may be generating electromagnetic interference. The buzzing could potentially be related to ground loops. Ground loops occur when there are multiple paths to ground in an audio system. This can create a difference in potential between different parts of the system, which can then cause a current to flow between them, resulting in noise. To troubleshoot ground loops, firstly, use a multimeter to check the ground resistance between different components of the audio system. The resistance should be as close to 0 ohms as possible. Secondly, ensure that all audio equipment is plugged into the same outlet or power strip. This helps to ensure that all components are sharing the same ground reference. Thirdly, use balanced audio cables whenever possible. Balanced cables are less susceptible to ground loops than unbalanced cables. Fourthly, if a ground loop persists, try using a ground lift adapter on one of the audio components. This will break the ground loop and may eliminate the noise. It is important to note that using a ground lift adapter can be dangerous if not done properly. It is always best to consult with a qualified electrician before using a ground lift adapter. Another potential issue is a neutral ground fault. A neutral ground fault occurs when the neutral wire in an electrical circuit comes into contact with the ground wire. This can create a path for current to flow through the ground wire, which can then cause noise in audio equipment. To troubleshoot a neutral ground fault, firstly, use a multimeter to check the voltage between the neutral and ground wires. The voltage should be as close to 0 volts as possible. Secondly, if there is voltage present between the neutral and ground wires, disconnect all electrical equipment from the circuit and check the voltage again. If the voltage is still present, there is likely a neutral ground fault in the wiring. Thirdly, carefully inspect the wiring for any signs of damage or loose connections. Pay close attention to the points where the neutral and ground wires are connected. Fourthly, if you are unable to locate the neutral ground fault, contact a qualified electrician to assist with troubleshooting. Identifying the exact cause of the buzzing can be challenging, so a systematic approach is recommended. Start with the most basic and common causes and then work your way up to the more complex issues. Document all troubleshooting steps taken and any changes made to the system. This will help to keep track of progress and avoid repeating steps. Here are some additional considerations. Firstly, check the incoming power quality. Poor power quality, such as voltage sags, surges, or harmonic distortion, can cause audio equipment to malfunction and produce noise. Use a power quality analyzer to measure the voltage, current, and harmonic content of the incoming power supply. If the power quality is poor, consider installing a power conditioner or uninterruptible power supply. Secondly, inspect the audio cables. Faulty or damaged audio cables can introduce noise and interference into the audio signal. Check the cables for any signs of wear, such as frayed wires or loose connectors. Replace any damaged cables with new high-quality cables. Thirdly, test the audio equipment in a different location. If the noise disappears when the equipment is moved to a different location, this suggests that the noise is caused by something in the original location, such as electromagnetic interference or a ground loop. Consider relocating the equipment to a quieter location or taking steps to mitigate the source of the noise. Fourthly, update the firmware of the audio equipment. Firmware updates often include bug fixes and performance improvements that can resolve noise issues. Check the manufacturer's website for any available firmware updates and follow the instructions to install them. Fifthly, consult with an audio professional. If the troubleshooting steps do not resolve the noise issue, consider consulting with an audio professional who can provide expert advice and assistance. They may have specialized equipment and knowledge that can help to identify and resolve the problem. If the new circuits are installed, ensure that they adhere to all applicable electrical codes and regulations. This will help to ensure the safety and reliability of the electrical system. Consider using a dedicated electrical panel for the audio equipment. This can help to isolate the audio equipment from other electrical devices and reduce the risk of interference. It is also beneficial to label all electrical circuits clearly. This will help to avoid confusion and make it easier to troubleshoot problems in the future. A systematic and thorough approach to troubleshooting is essential to resolving noise issues in audio equipment. By following the steps outlined above and considering the additional tips, it is possible to identify and resolve the root cause of the problem. Remember to prioritize safety when working with electrical equipment and to consult with a qualified electrician if necessary. The new circuits that are being installed for the amplifiers should be installed properly and according to code. Proper installation of the circuits is critical to minimize any potential issues that could arise from poor wiring practices. Firstly, use the correct gauge wire for the circuit. The wire gauge must be appropriate for the amperage of the circuit to prevent overheating. Refer to the National Electrical Code Table 310.15b16 for the correct wire size based on the ampacity and insulation type. Secondly, properly terminate all connections. Ensure that all wire connections at the electrical panel, receptacles, and equipment are secure and properly tightened. Loose connections can cause arcing and overheating, leading to electrical problems. Thirdly, use appropriate conduit or cable protection. Protect the wiring with conduit or cable trays to prevent physical damage. This is especially important in areas where the wiring may be exposed to mechanical stress or environmental factors. Fourthly, ground all equipment properly. Grounding is essential for safety and to minimize electrical noise. Ensure that all equipment is properly grounded to the electrical panel. Fifthly, label all circuits clearly. Label each circuit breaker in the electrical panel with a clear description of the equipment it serves. This will make it easier to identify and troubleshoot any issues in the future. Sixthly, test all circuits after installation. Use a multimeter to verify that the voltage, current, and grounding are correct for each circuit. This will help to ensure that the circuits are functioning properly and safely. To minimize electrical interference, the air conditioning unit and the sound equipment should be on separate circuits. The air conditioning unit draws a large amount of current when it starts up, which can cause voltage fluctuations in the electrical system. This can interfere with the operation of the sound equipment, causing it to produce noise or malfunction. The power conditioner will filter out any noise and interference from the electrical system, ensuring that the sound equipment receives a clean and stable power supply. The power conditioner will also protect the sound equipment from voltage surges and spikes, which can damage sensitive electronic components. In addition, consider surge protection. Install surge protectors at the electrical panel and at the receptacles where the sound equipment is plugged in. Surge protectors will help to protect the equipment from voltage surges and spikes caused by lightning or other electrical events. And isolate sensitive equipment. Physically separate the sound equipment from other electrical equipment that may generate noise or interference. Keep the equipment away from motors, transformers, and other sources of electromagnetic radiation. A final consideration is to use balanced audio connections. Balanced audio connections are less susceptible to noise and interference than unbalanced connections. Use balanced connections wherever possible to minimize noise and interference in the audio system. Using shielded cables is also very important to prevent electromagnetic interference. Shielded cables have a layer of conductive material, typically a braided or foil shield, that surrounds the inner conductors. This shield acts as a barrier to block electromagnetic interference from entering the cable and interfering with the signal. Grounding the shield is important for proper operation. The shield is typically connected to ground at one or both ends of the cable. This provides a path for the electromagnetic interference to be dissipated, further reducing its impact on the signal. There are different types of shielded cables available, including coaxial cables, twisted pair cables, and multi-conductor cables. The type of cable that is used will depend on the specific application and the type of signal that is being transmitted. Shielded cables are commonly used in audio, video, and data transmission applications. They are essential for ensuring high-quality signal transmission and preventing noise and interference from affecting the performance of the equipment.